Alright, ladies and gentlemen, quick video to help you with the coordinate geometry, the equations of a linear graphs. Chapter 10.1, I think. Questions, some revision. Alright, first one here gives us 2 points. And they ask us to find the midpoint. Remember the formula for the midpoint. You need to memorize this. Point is a coordinate point, so it's got 2 brackets and a comma. You have to add together the 2 x coordinates and divide it by 2, and you have to add together the 2 y coordinates and divide it by 2. So let's label these. This is the first x coordinate and this is the second x coordinate. This is the first y coordinate and the second y coordinate. Okay, so what we're going to do here is we're going to do minus 1 plus 3, then divided by 2, and we're going to do minus 4 plus 8. If you do swap these two around, that's not a problem, just don't swap the x and the y around. Minus 1 plus 3 being 2. 2 divided by 2 is 1. Minus 4 plus 8, or 8 minus 4, is 4. 4 divided by 2 is 2. And that's it. This is find the equation of the line. Okay, so in the equation, they give us the formula. First, we need to find the gradient. Here's the next formula you need to remember. The gradient m is the change in y. So it's y1 minus y2 over x2 minus x1, the change in x. Okay, so we already labeled our coordinates there, so we can first take the y2, which is 8. Then there's a minus in the formula, so we're going to put it. And then y1 also has a minus. Be very careful here not to put the wrong amount of minuses. There's a minus there and a minus there, it makes 2 minuses. Then we take the x2, which is 3. Then the minus, and then the minus 1. 2 minuses making a plus, so 8 plus 4 is 12. And the same here, minus minus makes a plus, 3 plus 1 is 4. And that gives us 3. So now we can already write the equation. Y equals, the gradient is 3x. We now need to find the c value, the y intercept. Okay, so let's write this down. So what we have y equals 3x. We don't have the c, so we're going to put plus c. We do have x and y values. We got there a minus 1 and a minus 4, and we got there a 3 and an 8. So we can take any one of these x and y values. Probably easier to take the positive one. So let's do that. You see, y is 8, so we change this y for an 8. And x is 3, so we change this x for a 3. 3 times 3 being 9. Let me just move the 9 to the other side, which means 8 minus 9 being minus 1. And that's the c value, so now we can put minus 1 here. If you want, you can always check your answer. Because if we put these y values into these equations, we should get the same answer. It's the same equation, and they're both on the line. Okay, so let's try that. So instead of putting 8, I'm going to put minus 4 for the y value. Then 3 is the gradient. And then instead of putting 3, I'm going to put minus 1 for the x value. So minus 4. 3 times minus 1 is minus 3. Move the minus 3 there. It becomes plus 3. Bam. We get the same answer as we should. And now we know we got it right. Let's go on to the next question. Here they give us 2 lines, they give us the coordinates, and they want us to work out the equation of BC. Okay, this time they don't tell us how to write it, but we need to know when they ask the equation of a line, we need to write it as y equals mx plus c. So again, we need to find the gradient and then the y-intercept. If you can read my ugly handwriting, it says y-intercept. Yeah. Okay, so again, let's start with the gradient. The formula being y2 minus y1 over x2 minus x1. So we're doing BC. So B, I'm going to make that 4. I'm going to make that x1. And the C, going to make that x2. So that means this is y1 and y2. So to find the gradient, y2 is 4. Then the minus in the formula. And then there's a 1. So there's not another minus this time. And then the x2, that is 6, minus the x1, that is 4. Alright, so 4 minus 1 being 3, and 6 minus 4 being 2. Alright, and that's got it. So now we can write down y equals 3 over 2x. Got the gradient. But we still need the y-intercept, so let's do that. Let's say y equals 3 over 2x plus c is the c we have to find. Again, we can use any one of these coordinates. Let's use the one that's smaller. Okay, so y is 1, so change this y for a 1. And x is 4, so change this x for a 4. You can use your calculator to do this, but without a calculator, this line means divide, of course. So we need to divide 4 by 2, which is 2, and times it by 3, which is 6. Like 1.5 of 6. Move the 6 to the other side, because 1 minus 6, which gives us minus 5. Does that make sense? This line BC, if we continue it, where will it cross the y-axis? Could it be at minus 5? Yes. If we had to continue this graph, this line could possibly cross at minus 5. That makes sense. So we can put the minus 5 at the end. Okay. But if you want to check it, we can do it all again and use these coordinates. So in this coordinate, y is 4. So instead of 1, I'm going to put 4. 3 over 2. And then if y is 4, x is 6. So we do the same. 6 divided by 2 is 3. 3 times 3 is 9. Move the 9 to the other side. 4 minus 9. C is minus 5. We know we got it right. Okay. Then ask us to calculate the length of the line AB. Be careful. This is a different one now. Okay. So I'm going to relabel my points here, because now we're doing AB. We're going to make this x1 and this x2, and this y1 and this y2. Next, we need to remember the formula for the length of a line. Okay, is square root, because it's Pythagoras, x2 minus x1 squared, don't forget the square, y2 minus y1 square, and this line needs to go all the way. So let's do that. Okay, x2 now is 4, so this will be square root 4. Then there's a minus in the formula, and then it's x1 is 1 squared. y2 is 1 minus in the formula, y1 is 3 squared. So we can put this in the calculator, just like we don't have to waste our time calculating in our heads, possibly make mistakes. If you want to, you can do it in your head. 4 minus 1 is 3, so that makes it 3 squared. If you want to make things shorter. Plus 1 minus 3 is minus 2. But if you square a negative number, it becomes positive anyway. So if you want to save time, I mean, you can just put 2 squared. Answer there being 3.605. Etc. That's good enough. You want to write that answer, you get full marks. If you're going to round it, 3 significant figures, 3.61. Right, last question here. Is angle ABC 90 degrees? 90 degrees, of course, being perpendicular. Okay, so we need to look here. We already did, let's do this in another color, it's orange. We already did the gradient of line BC. Okay, so for BC, the gradient is 3/2. Okay, now that's important because with perpendicular lines you need to invert the gradient and make it minus. So let's work out the gradient for AB. Again, we're going to use this formula, y2 minus y1 over x2 minus x1. Got here AB, so y2 being 1 and y1 being 3. Subtract 3. Same as the distance formula. In fact, this part, x2 is 4 minus 1. So 1 minus 3 is minus 2. 4 minus 1 is 3. Okay. Now that is good news. Okay, remember we can also write this as minus 2/3. Okay, because if we were to take this gradient of BC and we were to invert it, we swap it around, we get 2/3. Change the sign, this is positive, becomes negative. Look, that's exactly what perpendicular lines is all about. Okay, so that means they are 90 degrees. But the real reason is here, whenever you multiply the gradient of two perpendicular lines together, 3/2 times minus, you can put the minus at the top again, we should always get minus 1. So 3 times minus 2 is minus 6. 2 times 3 is 6. 6 divided by 6 is 1. So therefore, thus, it is 90 degrees. Because the two gradients together gives you minus 1. Okay. This is just some of the questions you need to know for the chapter 10.1. Remember, parallel lines always have the same gradient. Okay, study hard, be a genius, you'll do well. Bye-bye.